start the lecture from where we stopped.
Good morning, madam.
Right. So I hope now your LMS issues are okay. So I hope and you have downloaded the presentations as well.
Yes, madam.
So last week we started the lectures about discussing in a general discussion about the building services, right? So there we discuss what are why do we need building services, what are the main objectives of having building services, and then what are the different types of building services we have, and when you incorporate building services into a project, what are the things you should look at, right? All those details we discussed during the last lecture. Give me 1 minute. Computer has got slow. Right, so purpose of building services mainly to provide functionality, safety, and comfort. Right, and these are the building services mainly. Some of the major building services, right? And then we did this activity. Which ones are giving provide functionality, safety, and comfort. And as I hope you can remember, I told you this will depend on the nature of the project also, right? So some of the things required for the functionality of a building may not be required for another type of building. So that will depend and subjective to the nature of the building and the applications also. Right. So I think we these ones right also, right? So yes, we covered these slides also, right? Planning building services, what are the benefits when you start early? I think we did. Is that correct? We did these slides, right? Students, can you please answer? Or else I have to check the recording. We did this, right? As I can remember, we did, right? So these are the advantages you get when we start planning the building services from the first stages, right? So you can have a better estimate of the construction cost, and you can allocate the spacing without much problem, right? Because you know at the beginning what are the equipment that you have to install and what kind of space is required. And also because you plan everything from the beginning, aesthetic appearance of the building should be will be nice, right? Otherwise, if you try to incorporate building services later, there will be a lot of trunking and wires and all here going here and there, so that the overall look of the building will not be nice, right? But if you plan the building services at the initial stage, then you can think where you are going to put the trunking cables and all those things, ducts, and then you can plan it nicely so that you will not have any those things visible to the interior spaces, right? Okay, so you can hear me now?
Yes, madam.
Can you hear me?
Yes, madam.
Right. Okay, so then from there we have come to the end of the first lecture, right? So as I told you, these are the building services you will learn in this degree program as a whole. HVAC 1 and 2. We have one in this semester, another one in next semester, and then electrical installation technology, plumbing technology, lighting, building acoustic in the third semester. And in ancillary services, we do one module this time where you have the ELV systems and fire detection and protection. Next semester, we have another set of services under ancillary services too, right? So other than that, building management systems you will learn in sixth semester, and there are some other subjects that are like complementary for the building service, right? So only pure building services modules, these are the ones you are going to learn. Other ones are complementary subjects that you require as a building service professional in the industry. Okay, right. So today we have to start the discussion about data networks, right? Data networks in the system, right? So before talking about data networks, I hope I talked to you that day about IoT. Can you remember with the trends, about the trends when we discuss, I discuss about IoT. Anybody can remember what is the meaning? Meaning is Internet of Things, no? So what is the connection between this Internet of Things and building services? Anybody can remember?
Madam, it's based on the building main VMS system.
BMS is also part of the IoT. It can be done as a part of the IoT. So, but what is the connection that we are talking about now? IoT means Internet of Things, no? So, what is that? What does that concept has to have with the building services?
We can manage all of the services in from the internet to the internet.
We can control any all services via internet.
Yes, right. So yes. Now, basically, if you think of a conventional building service process, right? In a conventional building service process, what will happen is you will have, like, let's say you have some devices and you have another control or control cabling or communication method through which we control, right? So for AC, we have different control system, lighting, we have another control system, then plumbing, pumping, all those things you can control different system like that. Now, what is happening is these systems are interconnected, right? So that interconnection and the communication between the controllers and the devices, now we use like individual systems for each and every service, right? But when you come to Internet of Things, what will happen is most of these things will be connected through the internet or a net data network, right? So for example, your CCTV cameras and your NVR or the DVR, the recording device, will be connected through the internet. So these will be part of the network, right? So one camera will have one IP address, another camera will have another IP address, NVR or the DVR will have another IP address, and then they can communicate through the network. Like that, the lighting and the lighting controllers connected to the internet, right? Like that, that is the trend, right? So all the building services are gradually becoming IP based services. IP based means they can be directly connected to a data network, and through the data network you can do the communication. So then you don't need different control wiring for different services separately, right? Through one network all these communications can happen, right? So that is why now when you say data communication, it is not just only one service in a building anymore, right? So data communications mean networking. So that why I'm telling this is, for you it is very important that you have a good understanding about networking as building service professionals who will be working in the future, right? So now you are working. So that means definitely if you are in the building service industry, you will be here for about at least another 15-20 years, right? So in the 15-20 years, definitely all these building services are going to become IP based, right? Already, CCTV cameras are IP. Now you have IP CCTV, right? Like that, now even public addressing system, especially all the ELV services are little by little becoming IP, right? So after that, even the HVAC controlling, all those things will ultimately become an IP based system, because then it is very easy to maintain. You don't need separate systems for each and every service. All the devices can be connected to a one network, and through that network communication and controlling can happen, right? So because of that, you need to know a little bit you should have a good understanding about networking, because in future almost all the services will become, at least part will be networking. So if you are a building service professional, a good fundamental knowledge about what is a network, how the devices connect, how they communicate, those things are important, right? So that is why I told you at the beginning, this data communication part, you may think that it is not very relevant, and some of you may have like mechanical and civil background, so you will think it is hard, right? but it is not actually hard, a very interesting and subject that you should know, because in the future definitely everything will going to become a part of the network. So in that kind of scenario, it's very important that you have a basic understanding at least about networks, right? So that is what I want to tell you. Now, before we start that discussion about the data networks, I want to show you a video. It's actually called one of the greenest buildings in the world. It's not a very recent one. I think this building was built somewhere around 2012 or somewhere around that. But it is actually called one of the greenest buildings because that building has so many different new implementations of building services. They have thought about sustainability, energy efficiency, and they have these services connected through the internet or data network, right? So there are so many new things you can see in that project, right? So we will watch that video, and later we will have a discussion about what are the new things that they have done in this building, right? So now we will watch that, and then we will continue the discussion, right? So please try to understand what are the new services that have been implemented, or what are the new things that they have done.
There's a new edition.
You can hear the sound, right?
Yes, madam.
Right.
There's a new addition to the Amsterdam skyline, a landmark office building that is pushing the envelope in terms of design and sustainability. An architectural gem located in the very heart of the economic and financial center of the Netherlands, meeting the requirements of the modern-day client, offering the new office experience. The Edge, the most innovative and sustainable office building in the world. The unique design and orientation of the Edge is based on the path of the sun. The glass facade on the north side of the building bathes the workspaces in daylight, while the solar panels that are placed on the southern facade shield the workspaces from the sun and generate enough sustainable electricity to power all smartphones, laptops, and electric cars. The solar panels that cover the roof provide electricity for the aquifer thermal energy storage that generates all energy required for heating and cooling the building. The aquifer thermal energy storage consists of two 130-meter deep boreholes in combination with heat pumps. The Edge endeavors to include as much of the surrounding environment as possible in its sustainable practices. Even the temperamental Dutch weather is put to good use, including rainwater, which is collected to flush toilets and to irrigate the ecological terrace and other garden areas surrounding the property. Being one of the most innovative buildings in the world, the Edge is equipped with a custom-made, state-of-the-art connected lighting system. With over 6,000 LED luminaires, the connected lighting system uses the building's lighting infrastructure for more than just illumination. Every second luminaire is equipped with a multi-sensor that measures movement, light, temperature, and infrared. Each luminaire is uniquely identified and seamlessly integrated into the IT network of the building. The connected lighting system offers exciting new opportunities to different users of the building. Comprehensive data is gathered and processed by Deloitte Data Analytics. This information is presented to the facility manager on a dashboard, which provides access to real-time and historical information about the building's usage, enabling this person to precisely monitor and manage every facet of the Edge. When an office floor is empty, all lights are automatically switched off, and ventilation is set to a minimum. As soon as someone arrives in an office space, the connected lighting system provides 300 lux illumination and adjusts the ventilation to the desired level. Employees can also act as owners and operators of a space. With a smartphone or tablet, they can set the temperature and lighting to support their individual preferences. The app also enables them to view and monitor their sustainable behavior. One can always. The atrium is the breathing heart of this new and exciting business community. Secondary air from offices is transferred into this majestic open space. When it reaches the top, the air is passed over two thermal wheels and released out of the building. At the same time, fresh conditioned air is blown in at the ground level. The atrium makes corporate interactions more enjoyable than ever before. The Edge is ahead of its time. This unique building utilizes a combination of environmental and technological innovations to create a truly revolutionary business ecosystem. Not only good for the inhabitants, but also good for the environment.
Okay, so you want to see it one more time?
There's a new addition to the Amsterdam skyline, a landmark office building that is pushing the envelope.
I think it's better that we watch it one more time to gather the information, right? So I will play it one more time.
Addition to the Amsterdam skyline, a landmark office building that is pushing the envelope in terms of design and sustainability. An architectural gem located in the very heart of the economic and financial center of the Netherlands, meeting the requirements of the modern-day client, offering the new office experience. The Edge, the most innovative and sustainable office building in the world. The unique design and orientation of the Edge is based on the path of the sun. The glass facade on the north side of the building bathes the workspaces in daylight, while the solar panels that are placed on the southern facade shield the workspaces from the sun and generate enough sustainable electricity to power all smartphones, laptops, and electric cars. The solar panels that cover the roof provide electricity for the aquifer thermal energy storage that generates all energy required for heating and cooling the building. The aquifer thermal energy storage consists of two 130-meter deep boreholes in combination with heat pumps. The Edge endeavors to include as much of the surrounding environment as possible in its sustainable practices. Even the temperamental Dutch weather is put to good use, including rainwater, which is collected to flush toilets and to irrigate the ecological terrace and other garden areas surrounding the property. Being one of the most innovative buildings in the world, the Edge is equipped with a custom-made, state-of-the-art connected lighting system. With over 6,000 LED luminaires, the connected lighting system uses the building's lighting infrastructure for more than just illumination. Every second luminaire is equipped with a multi-sensor that measures movement, light, temperature, and infrared. Each luminaire is uniquely identified and seamlessly integrated into the IT network of the building. The connected lighting system offers exciting new opportunities to different users of the building. Comprehensive data is gathered and processed by Deloitte Data Analytics. This information is presented to the facility manager on a dashboard, which provides access to real-time and historical information about the building's usage, enabling this person to precisely monitor and manage every facet of the Edge. When an office floor is empty, all lights are automatically switched off and ventilation is set to a minimum. As soon as someone arrives in an office space, the connected lighting system provides 300 lux illumination and adjusts the ventilation to the desired level. Employees can also act as owners and operators of a space. With a smartphone or tablet, they can set the temperature and lighting to support their individual preferences. The app also enables them to view and monitor their sustainable behavior. One can always work greener. The atrium is the breathing heart of this new and exciting business community. Secondary air from offices is transferred into this majestic open space. When it reaches the top, the air is passed over two thermal wheels and released out of the building. At the same time, fresh conditioned air is blown in at the ground level. The atrium makes corporate interactions more enjoyable than ever before. The Edge is ahead of its time. This unique building utilizes a combination of environmental and technological innovations to create a truly revolutionary business ecosystem. Not only good for the inhabitants, but also good for the environment.
Okay. Now, can you tell me what are the
There
new things you saw? New implementation, new things in building services, what they have done? Yes, what are the things what are the interesting or new things or innovative things they have done?
Smart lighting system.
Use natural lighting.
Okay, wait. Now, smart lighting system means what? Can you explain what they have done? What is this? What is different from a normal lighting system there?
Sensor, thermal sensor.
It can be managed using
Level.
network.
User can control the light and
User,
thermal.
yes, users can control the lighting level and the temperature, right? So that is one thing. Yes. So that means definitely the lighting and the part of the HVAC system should be connected to where?
Smart,
To what?
smart wall.
Sorry?
IP.
Smart,
They should be connected to the phone, right? So there should be a connection between the phone's lights and the HVAC system, right? So that means those devices has to be connected through the network. They can communicate, right? So that is how no phone can control the lighting and the temperature. So that is correct, right? One thing, right? What are the other things? What are the other new things you saw? There were so many things.
Using natural lighting.
Okay, using natural lighting.
Building directions.
using fresh air.
Thermal energy storage.
Yeah, geothermal energy, no? Right? So geothermal energy they are using, right? That means they are using the heat or the temperature inside the building to heat their things and also the storage, right? Did you see now they had two solar panels, no? One set of solar panels on the walls that they used for charging, charging phones, laptops, electrical vehicles, those things. And then they had again another one. The rooftop solar was used to do what? This
energy storage consists of two 130-meter deep boreholes in combination with heat pumps. The edge
right. So they are
endeavors
using
to
the geothermal energy and the solar generated energy to keep their environment. I mean, it's a country with where they have the winter and the summer both, right? To as required during the summer and the winter to heat and cool the environment as required. They are using geothermal energy also, right? Okay. So yes, what are the other things?
Ventilation, open space.
Can you speak a little bit louder? I can't hear properly.
Ventilation system.
Yes, so they have a new type of ventilation, right? So the fresh air is blown down and through that open space, they have used that kind of different ventilation system, correct? What are the other things? What are the things that makes this building green? So it's called the greenest building, no? One of the greenest buildings in the world. So greenest means we discussed earlier, it should be a sustainable building, right? So what are the other things?
One man can control the whole building in one place.
Yes, right. So there are a lot of controllability, right? So a building management system, and also it is connected through the network to all the devices. So there are a lot of information gathered. So it's very easy for the facility managers and energy managers to like control the services, monitor where the energy is used most, and how to see where you can save energy, because you can get lot of data is collected through the system. So you can look at all data and understand why you have used more energy during these months or like that, and then change and do the necessary changes, right? Correct. So that is basically building management system. What do they mention here?
Water treatment and is not the
Rainwater system, right? Rainwater harvesting system is used for irrigation and used in the toilets, right? So that is another one. So this one you said, no? So in the light itself, they have the other sensors as well, right? So they talked about 3 sensors here. What are the 3 sensors? In the light itself, they have fixed 3 sensors. What are the 3 sensors?
Motion sensor, lighting sensor, and heating sensor. Heat.
Temperature, right? Yes, heating, lighting, I mean the motion, whether the people are there or not.
Right.
Yes, and the lighting level and the temperature, right? So all are monitored through the lighting system, and all these lights are connected to the network, and from the network is connected to the building management system. So in the building management system, you can easily identify which places the people are there, which places you have more lighting from the natural lighting, and then according to switch off the lights, and then where you have more temperature, where you have more less temperature, all those things can be measured and data can be collected very easily through this system. So here they show, right? So all these lights have IP address. So these are the IP addresses, right? I hope you have heard about IP address. We will learn in detail in the today's lecture, right? So all these are connected through the network, right? They are like the computers in your network. So this person can see, right, how much energy is used during the day, how the energy usage is changing. Those things can be checked, right? So where the people are in the floors. So even now, because that people are using app, right? So through that app, can you see these people, different people, at what time they have come to the office, and what is their location, all those things you can see, right? So even the visitors, they have used some kind of, they must have asked the visitors to use the app, and from that they can check that also, right? So this is also working as a security system as well, right? Because you can see where the people have gone, where they are now, like that, right? So when the person comes in, automatically lights switch on and they come to a certain light level. And after that, if he wants, he can start, they come to 300 lux, right? So that is the standard level. So from there, if he wants, he can increase or decrease the lighting level. Right, so this is the pressure and the cooling arrangement. Right. So, and also here, they have 2 solar systems, right? So, and one more thing, what was mentioned here? Building orientation, right? So when you build a building, it is very important that you think about how the sun is traveling, or what is the path of the sun, and which direction you will get more sunlight during the year, which direction you will get more heat during the year, and according to that plan the building. For example, now from the south they get lot of daylight, because of that they have made this part a glass facade to take the light in, right? So this side, from the north side, they get lot of heat. So that area, if you open, right, so you will get lot of heat inside to the building, which will increase your air condition load. So because of that, they have used solar panels in that wall, right? So to get that heat, and from that heat generate energy, right? So the orientation of the building, how you build the building in the land plot you have, is also very important when we talk about sustainability. Right? So we will learn these things in detail later. Right. So now, now if I asked you as users, do you like to work in this kind of a building? What is your answer? Do you like to work in this kind of a building?
Yes.
Yes.
Yes. So why? What is the reason? What are the reasons you say yes?
Comfortable.
Okay. Comfortability is there. Is that all? Comfortability means you have the good lighting level, good air conditioning, those things. Is that all?
Efficiency.
Easy to
Right.
work.
Easy to work, right? So it has a like a work friendly environment. No, lot of you can, like if you want, you can change the environmental condition as per your requirement. You have a lot of daylight which will like make you more efficient and more awake kind of thing, right? So there are so many benefits that you can get and you will be proud, right? So your building, your office building or your place is saving so much of energy and doing lot of good things to the earth, right? So that is also, as a responsible people in a society, we also should think about that, not only our comfort, right? What we are doing from our activities to the environment, right? So because of that, like when you do this kind of when you work and live in this kind of buildings, people feel more happy and they will be more like they will be able to achieve the goals they have better, right? And I wanted to show you one more thing, that we talked about green buildings, right? And then I told you there are different like energy certifications you can get, right? So I told you in Sri Lanka we have a green SL rating. Green SL rating means it's a Sri Lankan rating system, and you can get platinum, gold, like that, right? And I told you the most common, most international recognized one is called LEEDs, which is given by the United States, right? United States Green Building Council, US Green Building Council. And these people, this building has taken this one. They have gone for a different rating system called BREEAM, right? So BREEAM is a British system, UK Green Building Institute. They are giving this BREEAM standard, right? So they have given 5-star or the outstanding rating, right? So when you try to get a rating or certification from this institute, they will rate you whether you're silver, gold, or platinum, or like that, or 1-star, 2-star, like that, right? So this building has gone for BREEAM certification, and they have got 5 stars, so outstanding status, right? So this is one way. And then if you go for LEEDs, you can get platinum certification, right? So green is Sri Lanka ratings also green. They have green, gold, silver, like that, right? So this is the certification that they have got for the sustainability and the new things that they have done in their building, right? Okay. Right. So now we'll move to our today's lecture. Right. You can see the slides, no?
Yes, madam.
Right. So data communication systems in buildings, right? So now it has become an essential part of any modern building. You must have a data communication system. Now, although it is earlier was a computer network, right? Now it is called actually a network of devices, right? So even a very simple office, if you have a network only to connect your computers only, at least you will have a printer connected to the network, right? So you can send the documents to the network to the printer, and then you can take printouts, right? So like that, now it is not a network of computers anymore. Now it's a network of devices. You have so many different devices like computers, CCTV equipment, access control equipment, lighting, sensors, and many more things, right? So from this video that we discussed, you saw there are so many things you can connect to a network, one network, and then through that network, you can get lot of benefits to the building. So because of that, it's very important that you have a good understanding about data communication systems in general, right? So in a data communication, now any type of communication, right? So what do you mean by communication? What is the general meaning of communication? How many ends are there in a communication process?
Minimum 2.
Minimum 2, right? So even this lecture that I'm doing now is a communication, right? So I'm saying I'm giving you some information which is starting from me, that is the source, and you are the end or the destination, right? So in this lecture we have like one source and multiple destinations, right? So it's actually kind of a broadcasting communication. I give you, I speak and many of you listen, right? So it's a broadcasting communication, right? So data communication, usually there will be at least two ends, right? Source and the destination. So sometimes, many cases, there can be multiple destinations also. So source and destination, or sender and receiver. For the communication to happen, it should happen through a medium, right? So there should be a way how the information sent by the source is sent to the destination, right? So there should be a path, right? Now, if you take a data communication network, right, usually there will be a computer or one device at one end, and then you have another server or something as the other end, right? So usually you have a source, and then there will be somebody called transmitter, right? So which will convert the information sent from the source compatible to the transmission system, right? Now, when you want to send something, right, so that you have to send, now if you are using some kind of transmission system, then it has to have a particular format. No, now let's say I'm sending a letter to somebody, okay? So what is the transmission medium I'm using? What is the system I'm using to send a letter from? Let's say I want to send a letter to one of you, right? So then what is the transmission medium I'm using? What is the system that I'm using to send this letter from my home to your home?
Register post.
Post, right? So postal service. Now, when you send a letter, or when you send, let's say I am sending a document, right? So when I'm sending a document through a postal service, can I just send my document to the post office and expect them to send it? Now I have a, let's say, some document to be sent to you. So I just go and give that document to the post office. So will that be sent to you?
No.
What do you think? Can I send the info? Can I send a document through the post like that? I have the document. Let's say I have a certificate. So I just go and give the certificate to the post office and ask them to send. So can they send it like that?
No, we can't.
No,
Can't.
right? So then what you have to do?
We should write address and pay money.
Yes. And then you, first of all, you have to put the certificate into envelope, right? And then the front face of the envelope, you have to write the address, and you have to write from whom it is sent, and then you have to pay and put a stamp, right? So there is a day processing you have to send, right? Right? Because I want to send my certificate to you, right? So that is my purpose. But to do that, you have to have some, you cannot directly send that document through the transmission medium, right? So there is a way or a particular format accepted by the transmission system, right? So you have to convert your document or your data according to that format. That means if you take the postal service, it is the envelope with the address and stamp written, right? So when you have that in that format only, they will accept, right? So there should be some processing happens from the source end, right? So that is the job of the transmitter, right? Transmitter will convert this data sent by the source, or whatever the message sent by the source, compatible to the transmission system, right? And then from the transmission system, that message or that information will go to the receiver, right? So the receiver will convert that information receiver will convert that information understandable or useful for the destination, right? For example, now when I send you the letter, what you will do is you will remove the envelope and then take the certificate, right? So that removing part is the job of the receiver, right? So if you think about normal internet communication, right? So let's say you from the computer, right? So we'll first see this. Source generates data to be transmitted. Transmitter will convert the data into a signal, right? Signal means the format which the transmission system understands, right? So then the transmission system carries the signal from point A to point B. Then receiver will convert that signal again to data, and the destination takes incoming data, right? So that is the data communication process, right? So this is the activity that you have to do, right? So explain what will happen when you access the Gmail or Facebook from your mobile phone or computer. With what destination your phone and the computer communicate. Is it one-way or two-way communication? What are the details your device will receive, right? Now first think, when you want to go to www.gmail.com or www.facebook.com, in that situation, what is happening here, right? So I will, like, for example, think of like this, right? From your computer, you type www.gmail.com and then you know your computer or your mobile phone is connected to a router. Now in a mobile phone, these two are connected, right? These two are one. So you type it on the phone. The phone itself works as the router because it is directly connected to the internet. And then something will happen and something will happen. And again, you will get your Gmail sign-in page, right? Now when you type www.gmail.com, you will get the Gmail sign-in page, right? So think of that process, how it happens. So you type www.facebook.com, then your Facebook login page will come, right? So how does that process happen? That is what I want to think about, right? So I will give you about 3-4 minutes and quickly put it into breakout room. So I want you to find answers for these questions. Okay. So right. So I will put you into breakout rooms, quickly find out the answers and come back in about 5 minutes. Right. So think, okay. You have to think. Now you cannot find this information from the internet. You have to think what is happening. Explain what will happen when you access Gmail or Facebook from your mobile phone or computer. With what destination your phone or computer communicate. Is it one-way or two-way communication? What details your device will receive? Okay. Right. Is it clear? You can take a screenshot of the questions. Right. So I will open the breakout rooms. You can quickly go and discuss and come back in about 5 minutes. Okay.
Recording in progress.
Yes. So can somebody tell me what you discussed? What will happen when you access the Gmail or Facebook from your mobile phone or computer? With what destination your phone and the computer is communicating? Yes. With what is their destination? Now, what really happens when you write www.gmail.com? What really happens? What is happening? How do you get that page back to your computer? Yes?
By executing the server.
By
Executing the server.
accessing the server, right? So Gmail or Facebook server, right? So that is, now when you type www.gmail.com, your computer will send a message to this server, right? So there is a process how you find from this www.gmail.com, which we call the URL. It will be converted to IP address. There is a different process for that. And from that, it will identify, okay, this is the destination to which I should send the information. So it will send, your computer will send a message to the server. Now I want to access your Gmail, right? So that will be what will happen. So is that a one-way communication? Or then what will happen? Then after that, what will the server do? Server will send, okay, then you have to send me the what? Username and the password. So that page where you should enter the username and password will appear in your computer, and then you will put your username and password. So that again will go to the server, and then server will verify whether they are correct, and if they are correct, they will show you an inbox of Gmail or your home page of your Facebook account, right? So that is what will happen. So this is one-way communication or two-way communication?
Two-way communication.
Yes?
Two-way communication.
Two-way.
Sorry?
Two-way communication.
Two-way communication, right? So you send some request, server sends an answer. Again, you send some request, again server sends an answer, right? So it's like a two-way communication happening from the source to destination, and then destination to source. So in one communication, your computer is the source and the server is the destination. Then again, the other, when the reply comes, the server becomes the source and your computer becomes the destination. Then again, when you send another request, your computer becomes the source, the server becomes the destination, right? That the role changes and a two-way communication happens, right? So ultimately, when you first send the request, your device will get that form where you have to put the username and password. So when you send that again it will send your inbox or whatever your Facebook home page or whatever, that information will be sent to your computer, right? So that like that, this is source, from the source to destination, and from the destination back to the source. Continuously this communication happens until the required information is gathered by the user, right? So here you can see this router. Okay, if you take for the simplicity, we will take the instance where you are connecting to a computer, because in the phone this the user device and the router both are combined together, right? If you are directly connecting to a mobile data, but if you are connecting your phone to a Wi-Fi router, again this scenario is there, right? So this router is actually the transmitter, right? It will convert whatever information sent from the computer compatible to be sent over the internet, right? Like that, putting that document into envelope, right? So that envelopes are what will be accepted by the postal service. Like that, there is a particular format of data that is accepted by the internet, right? To convert whatever information sent from here to that is the main work of the router. There are some changes, but for the simplicity, you can, for this level, you can understand like that, right? And from the router again, this information will be received and it will be passed to the server, right? So this we called actually a client and server model, right? So these, now if you take this, sorry. Right. So this format or this process that we talked about in the Facebook example or the Gmail example is actually called a client and server model, right? Why we call the client and server? Because there is a central server where the information or the services are there, right? The web application, the Gmail, Facebook, or whatever the other things that you access through the internet is usually in a server, right? So where there is a program running, right? So the clients can send, clients means the devices, the end devices, the mobile phones, the computers through which these users are trying to access the server for the information or the services inside the server, right? The client send a request and server responds with the requested information, right, which is happening through the network. So this is called the client server model, which is the basic understanding or the concept on which our data communication networks are formed or built, right? So we have servers where this central information or central applications or like central software or whatever is running. So the clients or the end devices or the users can connect to the network through the server and then access it, right? Now, for example, let's say if you are using your Word, right? Word software and writing a document, right? Now you are connected, you are working on this computer, right? And the application or the Word is where? Word software is running where? Now let's say you are typing some document in your computer, right? So the user is connected to this computer. I'm connected to my laptop and I'm typing a document in the Word application. Now this Word application is running in where? Is it running in your computer or somewhere else?
In our computer.
Sorry, in your computer, right? So it's an
Yeah.
application running on your computer and you are working on that, right? So that is normal working on a normal software. But here, when you say a client server model, it is different. Now, if you are accessing Facebook, right? If you are doing something on the Facebook, where this Facebook application is running, is it running in your computer?
No, it's on a server.
It's on the server, right? So you are actually working from a remote place and doing something on that software, right? So it's very simple format. It is like that, right? So that is called client server model, right? So the application or the data or whatever you are trying to access is not on your computer. It is somewhere else. So you are trying these different clients. So the different users are using the network to access this remote server and do something or take some information or whatever from that server where these applications and the information are there. Okay, right. So that is called the client server model, the basic concept on which the data networks are working. So client server model, as we discussed, what happens when you access the Facebook? The client send a request, send me my Facebook homepage. The Facebook server sends you the homepage. This is after you send the username and password. I have skipped that part, right? So, that is what is happening, right? So you will get this page to your computer, and from there you can do some changes, which will ultimately make some changes in the web application running here, right? So that is called the client server model. Right. So transmission technology, when you send information from one end to the other end, there are two transmission technologies, broadcast links and point-to-point links. Right. Now I told you this communication we are doing here, right? This communication that I am doing as a lecture here, it's a broadcast. What do you mean by a broadcast? Now we say television broadcast, right? What do you mean by broadcast? What is the difference? What is the thing you can identify me in this kind of communication?
From one point.
From one point it is generated, and then what about the other end?
Other point and only received.
Sorry?
Receive from many places.
Yes, received by, right? Received by many places. That means the destinations can be many, right? So sometimes if it is a broadcast, actually, if you say the correct example, now this is actually not my communication can be actually not, it's a broadcast, it's actually called, the correct word is multicast, right? Because here I have a control of who are the people that can receive my message, right? Now, I'm not, I will not let like people who are in the other universities or who are not our students to listen to this lecture. So only selected number of people will be able to participate for this lecture, right? So that means it's actually not broadcast, it is multicasting. But if I'm doing this on, let's say, YouTube, right? If I upload this lecture to the YouTube, then I don't know who will listen to this, right? So there will be number of receivers or number of destinations to which this message will go. So then it's a broadcast, right? But if you say point-to-point link means one sender, one receiver, right? Broadcast link means the number of senders, so the other end is unlimited. We don't know how many, right? So it can be received by many people. And then point-to-point means from one person to selected another person, or from one point to selected other point. So you exactly know who is the sender and who is the receiver, right? So these are two types of transmission technologies. Now in television, if you're saying not this POTV or cable TV, but you say the traditional television, it's a broadcast, right? So Sri Lanka Rupavahini Corporation generates the signal and send it over all over Sri Lanka. So anybody within the range can watch, right? So it's a broadcast, right? So in networks also you have something called broadcast links, right? So you know in network we have communication paths, right? So broadcast link means single communication channel connects all the devices together. Message sent by one machine is received by all the other machines, right? So now let's say there are 4 computers. 4 computers are connected to this line, right? So it is connected to line. So what will happen is when one body sends this message, right? This person sends the message, that message will go to this person, and then again it will go to this person, and again this will go to another person, right? So all the computers who are connected to this link will get the message that this first computer sent, right? So this message in the internet, we call them packets, or in data networks, we call them packets. We will learn later what is a packet exactly. Now think about the envelope in that post example, right? So in the postal example, the envelopes are what will go from one post office to the other post offices, right? So then like that in the data networks, we have something called a packet. That is a set of information that has a particular format. So these packets, like the letters, have an address, right? So when this computer sends the packet to the network, it will have an address. This message or this packet is for this person or this address, right? So when you get the message, now let's say this computer gets the message, he will look at the address. If it is your address, it will read the information. If not, it will disregard, right? The message has an address, so the device understands whether the message is for that device or not, right? So let's say now this computer sends a message, right? Where the address, let's say this is the address is A, right? Now this is A, this is B, and this is C. Let's assume like that, right? So when this packet is sent to the link, it will be received by A, the packet will go to B also, the packet will go to C also. So when the computer A receives this packet, it will look at the address says A, so the computer knows, okay, this is for me. So it will take the packet and read the information and do whatever required. So this same packet will go to B, and then B will look at the address. The address is A, that means that is not for me, so it will disregard, right? It will not do anything to the packet. Then C also will receive the packet, look at the address is not for me, so then it will disregard, right? So these broadcast links, so these kind of systems are used in very small networks. Why do you think they are only used in small networks? Let's say why are we not using them in this kind of communication method in big networks? What is the reason? Any idea why are we not using this kind of system? Let's say now here 4 computers are connected. Why can't you use this kind of arrangement when you have like 1,000 computers? Think what will happen?
Due to data traffic.
Sorry?
Due to data traffic.
Data traffic, right? Yes, correct. Right? That is what will happen. Now think he will send a one packet that will go to all the people. Again, now they are these computers are also working. So this one will also send a one that will also go to everybody. Another will be sent by this one that will go to everybody, right? So there will be so many data packets going here and there, right? Which will ultimately make the network get stuck because of huge traffic, right? So because of that, this kind of arrangement, broadcast links or broadcast communication method, you cannot use in large networks, right? So we use them in small networks, like small, now we call LAN networks, that means internal networks. Now, for example, in your offices or all your computers will be connected to one network, right? So that is not connected to the internet, right? So it is connected from one point, but each and every computers are connected. You are in a one small network. So in that kind of networks, we can use the broadcast links. That is what is happen, right? Broadcast link will happen in small networks, right? In a limited area. Or if you have a small Wi-Fi network. Now in your homes, maybe you have one Wi-Fi router and your several phones of your family members, and maybe the laptops are connected, and there you have one network, right? So you're from the Wi-Fi router, your mobile phones and the laptops are connected actually, although you do not communicate with each other. If you want, you can communicate, right? Because you are in one network. So those kind of small networks, this broadcast method is what is used. Okay, so that is called broadcast link. So any question about this? Because these are very important things. The basics that you need to understand very clearly. Any questions? Right, so if you don't have any questions, we will move to the next one. Point-to-point links, right? So devices are connected point to point. Between the connection between 2 points, there can be several other devices used when the distance between the devices are larger, right? So for example, this is a point-to-point network, right? Now this is connected to this one. This one is connected to this one. These two are connected like that. There are connections, right? Now let's say this is A, B, C, D, right? Okay, now there are directly connected devices. There are devices that are not directly connected. For example, if you take A and B, they are directly connected through this link, right? A and B directly connected. But if you take A and C, are they directly connected? A and C? No. Why? Why it will happen? Because A and C will be in two very different locations, larger distance between A and C, right? So if you say now you want to do a communication from A to B, right? So what will happen is this computer will send, let's say A wants to send some information to B, so it will send the information to B and B will read, and then they can do their communication. Now let's say A and C wants to communicate. So A will send a packet, right? A will send a packet, and the address will be what? Address of that packet will be what? A and C want to communicate. Now A has created a packet. And what is the address that A write in that packet?
C.
C, right? It will send it will write the address C, and it will go to where? First of all, this packet will go to where?
B.
B, right? It will go to B. Then B will look at, and then B will think, okay, this is not for me, this is for C, right? And the B knows, I am directly connected to C, right? So I am directly connected to C. So it will pass this packet, the packet it will receive to this end, right? Then then this packet will go to C, and then C will look at the address, okay, this is for me, it will read, right? So the in-between devices are usually not computers. Here it is shown as a computer, but they are not actually computers. These in-between devices usually are called, they have different names and they have different roles to play. We will learn later. They are called network devices, right? So here, this is a point-to-point one, right? So now let's say B wants to send some information to C, right? So then it will send only the packet through this link. It will not send the packets to all these other people, right? Only this link it will send, right? And compared to this, now see here, this is like a common road where you have access to different devices, right? But this is like dedicated routes from one place to other place, point-to-point links, right? So broadcast links are used in small networks. When you have large network communication, let's say this is A is your phone and this C is the Facebook server. So your phone is in Sri Lanka, Facebook server may be somewhere else in another country, right? So in that kind of like far distance communication, or when the two ends are very far away from each other, not in one network, these point-to-point links are also used, right? So these are just concepts. Just try to understand the concepts, because when we discuss further in our discussion, all these things will come into play in different places, right? So when you talk about network links, there are point-to-point links where you send one information from one place to the other person directly or through a intermediate device. So there, where you have dedicated links like this, right? Then broadcast means like this. You have a common path. You send the information to everybody, and only the relevant people will get the information. That is different methods. This is different method. Right. So in a point-to-point link consists of many connections between individual pair of nodes, right? So let's say now if you even in this example, right, if you want to communicate from A to C, you can go A, B, C, or you can go A, B, D, and C, right? So from A to C, there are two paths you can take, right? Like that, in a point-to-point system, there can be many connections between two nodes, right? If for example, if you go from A, if you have to go from A to C, there are so many paths you can take. Often multiple routes of different lengths are possible, right? So they have different lengths. End devices that wish to communicate are called stations, and the switching devices are called the nodes, right? So these are the end devices, the computers or the mobile phones in the network. These are called the nodes or the switching devices, which will send the information from one place to other place. For example, if A wants to communicate with E, A will send the information to 1, and then 1 will decide, am I sending this to 2 or 3? So it will make a decision and send it to 2. Then 2 will directly send it to only E. It will not send to other ones, right? So when you get the information, all these devices will make a decision to which path I am sending this, right? And then according to that, information will be sent. A data packet will have to pass many nodes to travel from one station to the other. For example, if A wants to send some information to C, it will have to go to 1, then go to 3, 5, or C. Or it can go from 1 to 2, 6, 5, and C, right? Like that. A data packet usually goes through many nodes before it comes to the end point. Okay, so these are just common things, but you will need them when we discuss the actual networking example. Right. So this is a comparison. Can you see the slide?
Yes, ma'am.
Right. So comparison between broadcast and point to point, right? In a broadcast, less bandwidth. That means you can send less amount of data at a given time period. Because why? When you send one packet, it will get copied and sent to everybody. So because of that, you cannot send more information, many information at once, right? You have to limit the amount of information sent. But in point to point, because you don't have that kind of data copying, you can transmit lot of data at once. And in broadcast, you can allow only one sender at one time, because when this one sends information, others have to listen, right? Others also can't send information. Then the information will get collapsed or they will get damaged, right? So one sender at a time. In broadcast, in point to point, you don't have anything like that. You can communicate, multiple people can communicate at once. So amount of new devices added is limited, because you cannot add, as I told you, you cannot add 100 or 1000 computers to this link, no? So you can, there is a limit of how much you can add. But here, you can, by adding more nodes, right? Adding more switching devices, you can expand the network very easily. System can be easily down when there is a fault. So if there is something wrong in this common path, the system will not work. But here, if one path goes wrong, there are multiple other paths you can go through. So because of that, you have better fault tolerance. Since only one channel is used, less expensive, right? So this is less expensive technology that you can use for small networks. More expensive as you need more transmission lines and switching elements, right? So which is obvious. Right. So what is a computer network? Computer network is a set of collection of computers and other devices connected together via communication devices and transmission media, right? So as we told, there are end devices, right? So these are the end devices, right? And then to connect these end devices together, you have the communication devices, and to connect everything together, you have transmission media or the cables or whatever links, right? So these are the three types of components in a computer network: end devices or the computers and devices, transmission media, and the communication devices or the switching devices, right? So computers and devices, they are the clients or the end devices which act as the end nodes of a network that require the communication, right? So for example, if you take here now, let's say this computer and this server, these are the end devices, right? So you need to have a communication between these 2 points, right? So that is why we have the data network. So these are the end devices. Computers and devices are the end devices that need the communication to happen. These devices could be such as computers, laptops, so you know, so many things, right? Mobile phones, tablets, POS machines means, what are POS machines? Point of sales machines. Any idea what is POS machines?
Cashier.
Yes, right. So those devices you have at the like shops, cashiers, from where you make the card payments, right? So you're there, that machine is sending request to the server of the bank, and through that transaction is happening, right? So those are called POS machines. Printers, scanners, barcode scanners, projectors, right? So there are so many devices, not only these ones. Now we know lights, CCTV cameras, so many devices you can connect to the network, right? So these are called the end devices, or the computers and devices. Transmission media is the physical mode of the computer network. It defines the system that is used to enable communication, right? So your transmission media can be coaxial cable, twisted pair, that means usual Cat5 network cable, fiber cable, right? Or Wi-Fi, radio frequencies. Now, if you take Wi-Fi, we do the communication through radio frequency signal waves, right? Or radio waves. So that is the transmission media, right? So through which the communication or the data sent from one location is going to the other location. That medium is called the transmission medium. And communication devices. Now we saw earlier in this kind of arrangement, right? So you cannot connect the end devices directly with each other, right? So there should be in between intermediate devices which are sending the data from received from one end to other locations, right? So these are called the communication devices or switching devices. They are the bridges that enable the physical transmission media to transport data from one place, from one end device to the other end device, right? So there are so many communication devices that we will discuss later, called network interface card, which is the card you have in every device that is connected to the network, right? So this network interface card is what is enabling your laptop to be connected to the internet or any network, right? So if you don't have the network interface card, you cannot connect your laptop or the desktop to a data network. Then you have routers, hubs, bridges, switches, so many different types of communication devices used in different places of a network to provide the communication. Right. Types of computer networks. Right. Types of computer networks. Computers can span from, or there are computer networks from simple home network where all mobile devices are connected to an access point or a hub, which is connected with a router to be connected to the internet, or to city national networks connecting together entire world, connecting together www, World Wide Web, right? So at your homes, as I told you, also you have networks. For example, let's say if you have a Wi-Fi router and your phone is connected to the Wi-Fi, and your wife's or your mother's phone is connected to the Wi-Fi, and let's say another laptop is connected to the Wi-Fi. So those two phones and the laptop is in one network, right? So usually we don't communicate from your phone to the laptop or between the two phones, but if you really want, you can do it, right? Why we don't do that is because we don't have that kind of requirement always through the internet. We try to communicate with the servers, right? So because of that, you don't feel that, but actually the devices in your home that is connected to one Wi-Fi zone are actually in one network, small home network, right? So for example, if you have a printer at your home, so you can connect your laptop through the Wi-Fi network you have to the printer, and then you can send your document to the printer through the Wi-Fi, and then it will print. Even your phone you can connect to the printer, right? So then you have a network. Even though you don't have a network, even your phones and the laptops that are connected to one Wi-Fi point are actually in one home network. So these are very small, simple home networks, right? And then you have, networks in your offices, right? Maybe where you have like 10, 15 computers or 150 computers connected to a network. So they are also in one network, right? So these are like middle level. Then what is the largest network that we have in the world? What is the largest network that we have in the world? Yes? That is the network that you access every day. What is that network? Yes?
Facebook.
Sorry?
Google.
No, Google is an application that is running in that network. What is the network? Google is an application. No, Google is one server that you are accessing to find information in that network. What is that network?
Wi-Fi.
www.
www. or World Wide Web, or as you generally understand the internet, right? So internet, can you tell how many devices are connected in the internet? We don't know, right? So many, like thousands and thousands devices from each country is connected to this one network, right? Internet or World Wide Web, as the technical word is World Wide Web, or we generally call it the internet, right? So there you have like the unknown number of devices connected together. So that is the network that where we have the entire world connected, right? Which is called the World Wide Web or the internet. So it's a very large network. So from very small networks of 1 or 2 devices connected inside a home up to the internet, there are different levels of networks. So according to the networks that we are talking about, the switching devices, the transmission media, and how they are connected together will be different. Right? So you have different levels of computer networks. Okay, right. So first, the below table can be used as a guideline to identify different types of networks, right? Remember, this is a guideline, not a rule, right? Exactly not this is that, right? So we talk about the inter-device distances and the area where the devices are located, right? For example, if your inter-device distances are within 1 meter, what is inter-device distance? The physical distance between two devices in the network. If they are less than 1 meter, or if they are in the range of 1 meter, and all the devices are located within 1 square meter, we call them personal area networks, PAN. Right? If inter-device distances are within 1 meter and the area, everything is connected is within 1 square meter, they are called personal area networks or PAN. Then if your the inter-device distance is within 10 meter to 100 meter, right? 10 meter within a room or 100 meter within a building, they are called local area networks or LAN. I'm sure you must have heard about this name, LAN, right? Local area network. For example, your computers in your building or in your office are usually coming as a LAN, right? If inter-device distances are within the range of 1 kilometer and they are in a devices are located within a campus. Campus means a large area, but usually belonging to one person, right? One person or one institute is called campus. Now, if you say, let's say in a university, usually, there are different buildings, right? Different buildings may be connected in a large area, right? If you think about a university like Peradeniya or Colombo like that, there are different devices, different buildings in a large area, right? So, but they are all owned by this same university, University of Colombo, University of Peradeniya. So then in that kind of one, not only universities, right? It can be sometime a hospital, let's say. Hospital, you have number of buildings in a large area, but they are all are like owned by this hospital, right? So then in that kind of situations, we call something called campus area network or CAN, right? So if you have multiple buildings within a certain area, that is called CAN, right? So if your inter-device distances are in the range of 10 kilometers, right? If you are trying to connect devices that are 10 kilometers away within one city, that kind of ones are called metropolitan area network or MAN. 100 kilometers within the country, worldwide area network or WAN, right? So let's say now you have, let's say one bank, let's say Bank of Ceylon. So they have different branches in different locations in the country, right? More than 100 kilometers, maybe more than 100 kilometers away from each other. But you need all the all the devices in these different branches connected to one network, no? That is how the banks work. So then it is a wide area network, right? Within the country, there are devices you need to connect together, wide area network. Then within the continent or like large areas, you again call even 1,000 kilometers difference is called WAN, and 10,000 kilometers within the world, everything connected together, that network we call as the internet, right? So this is a guideline. Remember, it's a guideline. According to the application only, you have to identify whether it's actually a LAN, MAN, or like that. Why have you sent these registration numbers? Students, why have you sent the registration numbers? For the attendance? Okay, right? So then personal area network. Personal area network is a computer network for interconnecting electronic devices centered on an individual person's workplace, right? Usually now, let's say the example that I gave you within your home, right? You have your computer and the printer and the mobile phone, everything connected to a Wi-Fi. Then it is called a PAN, right? So it can be computers, smartphones or tablets. It can be connected to a wired wireless system, right? Wi-Fi or normal network connection also can be there. Then local area network means network which connect computers and devices together in a limited geographical area, such as a home, school, office, or one building. Usually, if it is within one building, usually it is coming under local area network, right? This could be simple network of computers or devices connected together at home, or a large network of 100 computers connected together in a large central corporate office or a building. Can be wired, wireless, or combination, right? For example, now that, let's say that building that we talked about, that Amsterdam building, right? So all the computers, all the lights and CCTV camera sensors, whatever connected to that network is called LAN, right? Because it is in one building. Usually it is called a LAN. So there can be some of the devices connected through the wired parts. Some of them are connected through the wireless Wi-Fi. All of these devices are connected together in one network, right? So that is called a LAN. For example, here if you see, now these different types of computers, laptops are connected to a switch, right? They are all connected to a device called a switch. This is a network device or a switching device. And then through that, it is connected to the router. And from router, you are connected to the internet, right? So this part is called a LAN, right? Local area network. Now here you have a larger one, right? So you have some computers and a server connected to a switch. And then through the Wi-Fi, another few laptops are connected. And then again, another computer is directly connected to the router. This switch is connected to the router. This Wi-Fi is connected to the router. And this is connected to the internet. So this part is called a LAN, right? So other than the internet, whatever the things inside your building, combination is called the local area network. Okay? Right. So campus area network means, as I told you, network which made up of interconnection of LAN networks in a limited geographical area. Usually, let's say, campus area network is like in a university, or not only universities, even in office building. If you have several buildings connected together belonging to one institute, then it is called a CAN, campus area network. For example, now library will have one LAN, hostel will have another LAN, college or the another one will have one LAN, and these LANs are connected together, right? Why are they connected together? Because these are students. Why are you sending these registration numbers? Yes, why are you sending? Srimal, why did you send your registration number to the chat?
For attendance, madam.
Attendance, you have to put your name in the this thing, huh? Your name has to be with the registration number. Otherwise, I can't track these things, no? Okay, don't put messages, because when you put a message, I will check one by one whether you have sent a question. Attendance, you have to rename yourself with your registration number. That is how I take the attendance, because I can take a record from the Zoom or who have attended. So there your registration number should be there, right? So from your name only I'm taking attendance. Don't send messages. Okay. So if you have your registration number as your name of the participant, then it is fine. No need to send the registration numbers again, because when you send chat, I will check one by one again and again whether you have asked some question, because sometimes people ask questions through the chat. No, so don't send. Okay. So CAN is a connection of LANs together, right? When you have different LANs, but they have to be connected together because you are in one institute, then it is called a CAN, right? So this is also called campus area network or corporate area network. But remember, this is not only for universities, right? Any organization, number of different buildings that need to be connected together is called a campus area network or a corporate area network, CAN. Then metropolitan area network, right? As I told you, if there are different locations or different things within a town connected together. For example, if there is a, let's say there is some business organization where they have different branches, right? One branch in one area and another branch in another area and another branch in another area. You need to connect them together. They are in one town, right? So then it is a MAN or a metropolitan area network. Usually covers an area such as a city or a town. If there are different networks you need to connect within a city or a town, then we call that kind of networks MAN. And then wide area networks means if you have networks connected over a country, right? As I told, as the previous example, bank branches, right? Different bank branches are connected together. So then you have to cover a large area, right? So then WAN combines many types of media networks together, connecting entirely different geolocations. Because you have to go long distances, you have to use fiber optic. Maybe you will have to use different internet service providers. You have to some of, for example, some of the banks may be connected to dial-up. Some of the banks may be connected to SLT, and then they will be connected together through the internet, right? Like that, very large kind of networks will be there in a wide area network. So you have to use mobile broadbands like 3G, 4G, or fiber optic, like that. You have to use different transmission technologies for different locations because they are in between different parts of the country. You have to have multiple amount of types of connections from one network to the other network to create a wide area network, right? So we start from small PAN, personal area networks within a small room, and then in a building usually it is called a LAN. And then when you come to a city and connect them together, they are called MAN. And in a large country or all over the world is called a WAN, right? Okay, so there we will finish the lectures for today. So any questions? Anything you want to ask? Anything you want to ask? Right. So we will take a 1 hour break, 11:50, no? 11:55. So shall we start at 1 o'clock, then the lighting lecture? I will share you the link, right? 1 o'clock, you will have to join for the lighting lecture.